Today we're going to add and subtract expressions with like radicand. So this is going to be the same as if you are combining like terms. So if you have an x plus a y, you have x plus y. If you have an x plus x, we have a 2x. So what we're going to do is we're going to look right here at the radicand, the number underneath the radical sign. So we have square root 2, square root 2, square root 2. So that means we have like terms. So what this means, we're now going to take our 5 plus 7 minus 6. 5 plus 7 minus 6. And I'm going to write my square root 2 off to the side. Okay, if you have like terms, you do exactly what the sign says in front with just your numbers, and you add that. This would be the same as saying 5x plus 7x minus 6x. You still have to have an x in your answer, correct? So the square root of 2 is our x or our y. It's our variable. So what is 5 plus 7? Minus 6. 6. Our answer is 6 square root 2. Okay, so now let's look at this one. Right here, I have, remember the sign always goes in front. I have a 15 square root 3. I have a negative 11 square root 3. I have a negative 14 square root 5. And a 6 square root 5. So my square root 3's go together and my square root 5's go together. That's like having an x and a y in the same expression. So here we go. Let's deal with the oranges. We have 15 minus 11, and that's square root 3. Over here, I have a negative 14 plus 6 square root 5. So 15 minus 11 is? 4. So I have 4 square root 3. And negative 14 plus 6? Negative 8 square root 5. Okay. Now, we're going to add and subtract expressions with unlike radicands. The best thing to do is to we have to find a common radicand, okay? Find a GCF. We're actually going to use factoring here. So, what I'm going to do is over here, I have 4 square root 54. And what I'm going to do is I'm going to factor this. I'm going to factor my 54. I'm going to start with 2. I have 2 and 27. 27 is 3 and 9. Oopsie. 3 and 3. Okay. And then I have 2 square root 24. So I'm going to factor it to 2 and 12. 2 times 4. I keep messing up on that one. And 2 times 2. Wait, 3. 3 times 4. I think I said it right. I just wrote it wrong. Okay. Now, at this point, we're going to write out what we have. So in the pink, I have 4 square root 2 times 3 times 3 times 3. 2 times 3 times 3 times 3. Because isn't that saying the same thing as 54? Yes. In blue, I have, I'm right over here, 2 square root 24. Oh, no. Let me get my white out. We have to write out the factors. 2 times 3 times 2 times 2. I think I actually just put them in order. So let's write them out. We have 3 2. So 2 times 2 times 2 times 3. Okay. Now, what we're going to do, what we've learned about radicals, if there's a pair of a number, we can pull it out, right? Because 2 squared is 4. Square root of 4 is 2, correct? So, right here, I can pull this out because doesn't that make 9? And the square root of 9 is what? 3. So right now I have 4 times 3, square root of 2 times 3. Because I don't have another 2 and I don't have another 3, I can't pull it out. So this becomes 12 square root 6. Are we okay with that?
Yes.
Okay. So here, let's see, is there a pair I can pull out? Well, right there. Well, if you have 2 times 2 is 4, square root of 4 is 2. So we have 2 times 2, square root of 2 times 3. 2 times 2 becomes what? 4. 4 square root 6.
Ah.
So I had unlike radicands, I now have like radicands, and now we're just going to add them. So we have 12 square root 6 plus 4 square root 6. 12 plus 4 is 16 square root 6. You're done. Okay. I hope y'all can see that on the video. All right, use conjugates to rationalize a denominator. So yesterday we had to rationalize the denominator, but we didn't have something added to it or subtracted to it, okay? Today we have that. All right. So what we're going to do is we're going to use conjugates. Now a conjugate of 5 plus square root 2 is 5 minus square root 2. So it's the opposite sign. Conjugate is just the opposite sign. Okay? So we can write that down. Conjugate is just opposite sign. It's just a fancy word. Switch the sign. That is it. Now, how do we work the problem? We have 3. Oh, y'all can't see that. We have 3 over 5 plus square root 2. Now, if we had a square root in the denominator, what did we have to do yesterday? Multiply the numerator and the denominator by the same thing, right? We're doing that again, but we're multiplying it by the conjugate. So we're going to multiply by 5 minus square root 2 over 5 minus square root 2. Okay? We're still good. I promise. Now, what do we have? What's 3 times 5? 15. Okay? Minus, what we're actually doing here is we're distributing, right? Because we're distributing, let me show here. This times this and this times that. So what is 3 times like a negative 1? So it's negative 3 square root 2. Because you actually have, remember your 5 is a monomial. It is a term by itself. And the negative square root 2 is a term by itself. So we're distributing it to each term. Okay? So let's go down here. But down here, we're going to say, what is 5 times 5? And then you have square root of 2 times the square root of 2, which is, okay, it actually turns, no, you're right, hold on. It's the distributive property, and it will go all the way through. So, I'm going to show you why. 5 times 5, this is like FOIL. If you do 5 times 5, you have 25, correct? 5 times negative square root, you have negative 5 square root 2. Do you see that? And so we went first, outside, inside is plus 5 square root 2, and last gives us a negative square root 2. Square root 4, sorry. Because 2 times 2 is 4. This and this cancel each other out. Do you see that? I'll do another example here in just a second. But do you see how your center terms cancel out? So you have a 25 minus 2. Because square root of 4 is 2. I'll do another example. So we have 25 minus 2. 25 minus 2 is what? 23. So your answer is 15 minus 3 square root 2 over 23. So before I do another one with FOIL, let's practice. Oh, that's how I did that other one. It's really a difference of squares. Do y'all see that? Because look, you have the same A term, the same B term. You have a plus and a minus. Do you see that? So what is A squared? Hold on. Let me refresh your memory. I need a, right here. Let me refresh your memory. Difference of squares was A squared minus B squared, correct? Which was A minus B, A plus B, correct? So look, if you look here, you had 5 plus square root of 2, there's AB, and 5 minus square root of 2, AB. Are you with me? So what is 5 squared? 5 squared minus square root of 2 squared gives you 25 minus 2, because it's square root of 4. And I can write that out so you can actually see it. Which would give you square root of 4, which would give you 25 minus 2, which is 23. Does that help clarify the denominator thing? So it's difference of squares. So if you'll look at what is A and square it, what is the B, and you square it, you find the square root, you put the minus in between it. So it's differences of square on the bottom because we're multiplying it by the conjugate. You'll get the hang of it, I promise. Let's do another one. Okay, so let's do this one. What is the conjugate of this one?
3 plus square root of 7.
Yes. So we're going to write that conjugate. We're going to write it over here. Conjugate is 3 plus square root 7. Okay, and that's going to make us have a difference of squares on the bottom. So 7 over 3 minus square root 7 times 3 plus square root of 7 over 3 plus square, I wrote that wrong, 7. All right, so we're going to distribute on the top. 7 times 3 is 21. And then 7 times the 1 in front of our square root, it gives us what? Plus 7 square root 7, right? Okay, are y'all seeing that this is a term and this is the other term that I'm distributing to? Does that help a little bit if I highlight it? Those are the two terms I'm distributing to. Over, so what is 3 squared? 9 minus, if you have the square root of 7 times the square root of 7, you get the square root of 49, and the square root of 49 is 7. Okay, so now we have 21 plus 7 square root 7 over 2. It cannot be simplified. Do y'all see why you can't add those? Because you don't have another square root of 7, so you don't have like terms. You have a constant, and then you have like an x term, and you can't put those together. Okay, so go again. Okay, what is the conjugate of this one? 2 plus the square root. So we say 2 plus square root of 6 over 2 plus square root of 6. All right, now make sure that you're seeing the two terms, okay? And make sure that you are not multiplying this number by the number underneath, or by the radicand. Why can we not multiply the 5 by the 6, square root of 6?
Because that's the variable.
Yes, because it's going to be like a coefficient times your variable, but it's your number under your radicand. If they're not both under the radicand, you can't put them together. Okay? So, we have 5 times 2 is 10. And 5 times the square root of 6 is? 5 square root 6. Okay? 5 times the square root of 6 is 5 square root 6. Over, what is 2 squared?
4.
And you always put a minus. Square root of 6 times the square root of 6 is? 36. Square root of 36 is? 6. So we have 10 plus 5 square root 6 over negative 2. There's a pattern. The first number is squared minus, whoopsie, I put mind, minus the second number with the radical. And this is the denominator. We're talking about the denominator. And why is this true? Why is the first number squared minus the square of the second number with the radicand? Why is this working? Why is that pattern working?
Because you would square the first number, and then since there's no square root, there's no radical.
Yeah, but what's the term? What's the term that we've seen?
Square.
Difference of squares. Difference of squares is the reason that that's all working. Okay? I have a few more examples to show you. And I'll do that on part 2.